everyone. Thank you for joining us today on a Saturday morning, and welcome all for the CTOtalk 7th episode of Season 2. This is Janani, lead volunteer at CTOtalk, and today we're very happy to be hosting Mukul Joshi, who leads AI and ML at Turing. Before moving forward, I'll just grab a couple of minutes to take you through what CTOtalk and its journey for those who are new today in this room. CTOtalk is India's first and only knowledge sharing and networking platform for CTOs and engineers, and on a mission to help aspiring tech leaders to learn more deeply and collaboratively. We host discussions and produce resources around the topics of technology and engineering, and also multi-format content tightly curated to give deep insights into emerging tech solutions and tech trends. We've started with having monthly deep dive talks where CTOs, leads, or heads of engineers of a reputed brand walks in to reveal the tech stacks they have built, the engineering tech behind their product, and so on and so forth. And yeah, previously we've hosted offline events where people walk in to learn, share, and network among their peers and with the speakers. And with all the COVID situations, we've moved to virtual editions, and also it's happening. And now we'll soon be moving back to host offline events. We've had brands like Razorpay, Freshworks, Cred, Swiggy, Kissflow, etc. Startup Grind has been a partner and a backbone throughout this journey and helped us reach the right audience at the right time. And Kissflow is being a title sponsor and has helped us in many ways over a year now. So people in the room, if you are interested to volunteer to CTOtalk community, feel free to write to us at contact@ctotalk.in. I'll drop the ID in the chat right now. And we have Dinesh Kumar, who will be moderating today's session. Hi, Dinesh.
Hi, Johnny.
Dinesh is a Microsoft MVP award holder for the data platform category, and he's a product manager at Kissflow and also a lead volunteer at CTOtalk. He comes with 9+ years of experience with data and cloud. He's passionate about Azure and low-code. He has been co-organizing the tech community's event based on Microsoft Azure users for the past few years. Dinesh believes that holistic growth happens via knowledge sharing with the communities, and so we are. Before I hand it over to Dinesh, I'd like to take you through a few instructions. You can use the chat tab to interact and network with your peers and the speaker. You can use the Q&A tab to post your questions to the speaker. And also, there's this poll tab where you can order the polls that we'll be posting during the session. And and now over to you, Dinesh.
Thank you. Thanks a lot, Johnny. That's I think that's an insightful morning today. We have a lot of folks have spent their time to participate in this session. Thanks a lot for the audience first, and also Mukul Joshi, your valuable time. You have spent us here to share your knowledge. We are happy for that again. And yeah, it is a great privilege to introduce Mukul Joshi first. So Mukul Joshi is a successful entrepreneur with a total experience of 2 decades of experience. He has in not just in software product engineering, but also in research and technology as well. So as Janan told, he currently leads product engagements of artificial intelligence and machine learning teams at Turing.com. Earlier to this, he handled the supplies side of AI and ML at Turing. Prior to Turing means Mukul has worked as Senior Vice President of Technology and Engineering at Nitar Infotech, where he was also responsible for P&L of enterprise business. Mukul joined Nitar as a result of acquisition of his company named Spot On Software that he founded and grew over 10 years. Mukul has also worked in few research and development labs, including IBM Research in his earlier career. And of course, Mukul is an alumni of IIT Bombay. We are very happy to have such a person who has a diverse knowledge, having been from studied from IIT Bombay and been in tech and also research and also business as well. And of course, apart from his professional career, Mukil's hobbies includes in Marathi literature and music. So, of course, Mukul is an avid fan of Indian classic music, and he likes to play flute and harmonium as well. And I'll challenge guys, it is not an easy job to have something like head the AI and ML and do take care of the profit and loss in the enterprise business, and also still spending some time in literature and playing flute. And of course he'll be having a family as well, so balancing all these things are totally a great thing. So we are very happy to have you, Mukul, here, and the stage is yours, please.
Sure. So, thank you everyone, and thank you CTO Talk, Kissflow, and you know, Startup Grind, primarily for inviting me, giving me an opportunity to talk to such a interested and enthusiastic audience, which has gathered here on their weekend morning to hear a technical talk. So thank you everyone for being here. And as Dinesh told you that I am a part of AIML leadership team at Turing, and I plan to cover some aspects of AIML based product development, from my experience, and which I feel may be useful for a broader audience. Okay. Uh, Now, I have one disclaimer before I start my talk and share the slides. Uh, Turing is a 3+ year old company. We are a startup which has become successful in a very short time. However, a lot of machine learning related work at a deeper level is algorithmic and very, very core and linked to some of the business problems, right? And which makes it at times a bit difficult to have a boundary between sharing all the details and maintaining your IP and confidentiality and things that you have applied patents for and so on, right? So I am going to maintain that balance. I would rather feel ask you to feel free to pose any questions, okay? But if I feel that due to confidentiality I cannot go into it, uh, you will have to pardon me for that, and I request for that. So having said that, let's begin the talk, and let me try to share my screen. You guys can let me know once my screen is visible. I hope you can see the slides right now.
Yes, Mukul, we can see the slides. Yeah.
Okay. Now, I just want, before I begin, I want to first know, does everybody know about Turing, or how many people are here who really have just heard about it but don't have a clear enough idea of what we do? Okay. So I saw a few thumbs, so I am assuming that probably others are a bit aware, but not so much into the detail of knowing the business. And the important thing for any data science activity is to understand the business problem that it is going to solve. Okay. Otherwise, we can keep going into academic theoretical exercises over a long length of time, but that's probably how the industry differentiates from academia. So let's try to understand what we do at Turing. Dinesh, right now I can only see my screen. So the AirMeet section of question and answers or chat is invisible to me. But if anything comes up there, you please feel free to, stop me and call it out. Okay.
Sure, Mukul. Please go on. Please be comfortable with your side. I
Yeah.
will.
Okay. Fair enough. Thank you. So, you guys, as I said, you probably know this, but just in case, Turing is a AI-based platform. We are a company based out of Silicon Valley that recently raised its Series D at 1.1 billion valuation, and hence became a unicorn, right? It's a very recent thing. Turing could do this in a period of less than 3 years. Great success. So, what do we mean by this AI-based platform, and what all is it all about? Okay, so it is a talent platform. It is used by companies to hire global developers and do it fast. But why Turing is successful is because we serve certain use cases for our customers extremely well. And what is that? So finding high quality and remote developers, hiring them in approximately five days, 5 to 7 days time period. So, and save around 50 hours of interview time per candidate, plus engage the engineers with 97% of success rate. So the quality and the expectations are almost matched every time. Okay. We give customers a 2 week risk-free trial. So they can try a candidate for 2 weeks without paying a penny. Okay. Now this is why customers love Turing, and this is why it has grown. Okay. Now my talk today will be covering a few topics around it. Who am I? You already know. Thanks for the introduction. What we do and what makes us unique is important for us to understand the relevant data science issues or problems or solutions that I'm going to talk about. Second, I'm going to talk about Turing's data-driven culture overall. You know, it is not just an AI ML based product. It's a company that is built on an AI ML data analytics fabric. And I'll mention a few things around that to few of you. Then we can have a look at interesting AI ML problems at Turing. So I'm going to talk to you about the first point in such a way that actually I'm going to let you yourself understand and enumerate what can be the AI/ML problems at Turing. We will look at couple of examples of that. We'll look at the supply side and we'll look at the matching ranking side. And I'm going to speak a bit about engineering implementation for a very small time and about testing, okay, of AI/ML models. But yeah, this is primarily going to be the roadmap. I have a question now to frame, and I will be curious to know, are there any aspects of AIML work that you want me to cover, touch base upon, talk about, if possible during the talk, I can try that. So you guys can probably put it in the chat or Q&A part. I will wait for half a minute to just see what are the interest levels and what are the different things that people want to know about, they are curious about. Okay. So you saw why Turing and what it does for the customers, right? So in a short, you can spin up your engineering team with remote developers, providing great quality in absolutely lesser or least amount of time. Okay. What does it do for the developer community? It makes them apply to remote US software jobs from their own country. So no visa problems. They get complete good work satisfaction and experience of working for a Silicon Valley company or a US-based enterprise. Uh, they can do it from their home. They get paid better than their counterparts, and that's why it's a happy situation. Uh, what are the problems Silicon Valley was facing, or many of the US software zones were facing? The recruitment is limited to 10-mile radius. Okay. Now, if you are trying to hire a great AI ML expert, you only have options of a few people. Now it doesn't matter what kind of brilliance you apply on top of it to get the best one out of it or understand who is better amongst them. Your set itself is very, very limited. So you are all fighting for the same talent. That was one thing. So they were always thinking, how can you effectively source the talent on a worldwide scale? Some companies tried the outsourcing route. Some companies tried setting up offices, but there is always a limit to geographically how much can you scale, as well as what how much can you expand, because you can do it in either one country, two country, three max. Okay. Second was, how do you effectively screen and vet talent that you have ultimate excellent pool of talent. For example, we might have heard people saying that, "Yeah, I'm always sure about the person who comes out from Google or Facebook, and I'm never sure about the guarantee of the maturity or engineering architecture knowledge of somebody who is coming from a different country." Okay, so the quality becomes an important factor. And how do you make sure that the collaboration itself is effective? Uh, Even finding a right person is not the problem. Doesn't stop there. You need to work with that person. You need to collaborate with that person. You need to make sure that the remote work becomes successful. Now, what Turing is a platform where all the remote developers from the world, are available. Okay. So just because of that, just see how the location and dynamics and of the problems change. So now you have 10,000 cities, 140 countries, and 1.4 million developers. Now this was the number recent. It must have grown with that, but we had 1.4 million developers worldwide who have registered onto Turing. Okay, from 140 countries and so many cities. So for a particular job that is posted, there are almost 10,000 to 50,000 potential applicants. Okay. You want to choose the good candidate out of it, or the best match out of it. Now, this is not same as any other search. Okay. For example, when you want to search in a feed of Facebook, or when you want to search on Google, okay, you know, uh, the value or the return of the customer clicking on the right link is way, way, way more here, okay, because that customer is going to hire a candidate for you, okay. So matching ranking becomes the core. But the question is, it is based on what? Okay, based on what will you get the signals from? And we are going to look into that, and I'm going to address that. You know, however, if let's say the company does not have this option, then why is it difficult? Is because they need to first identify the right channels to find a suitable candidate. Then you start screening your candidate. Then you call the candidate for the soft skills interviews. Then you conduct technical interviews. Then you conduct your evaluation. Then you make an attractive offer, post which you onboard. Okay, this is way too lengthy a process without with a possibility of not having the guarantee of this working out, right? Uh, so what Turing is doing is, Turing provides the customers the weighted candidates. So you say that you come look at the Turing pool. We have already taken care of all of this. Okay, you just pick. Now we are, once the candidate registers, the candidate also uploads his CV or resume. They have to take certain tests on Turing platform. On an average, this waiting time that the candidate spends is about 4 to 5 hours. Okay, or so this is the time in which we complete our vetting of the candidate. And what all do we test in that? We get the signals around coding skills, system design skills, behavior and culture fit. There is seniority assessment that happens. There are 100 plus automated MCQ tests. Now, these are recommended to the candidate based on their profile. So they don't need to take so many tests. They just need to take probably two to four. Okay. But through that, their technology skills get vetted. And finally, their personal soft skills are also weighted. So Turing weighting basically tries to tick all of these things, and that's where the customer's job and time gets saved. Okay. Now, I'm just showing you a screenshot or a glimpse of our coding interview. So this is how our live coding interview looks like, right? So there is a problem given on the left side. There is a solution that the candidate is answering to, but it's not just an offline problem solving exercise. It's happening it's happening live. Okay. So we have coding tests as well as we have live coding interview. So this is where you not only get to see the coding skills, you also get to see the technical communication skills. You can also evaluate the approach and so many things. Okay. So now we are coming to the core of where data science starts making sense and starts becoming important. Now, this is how a developer's profile on Turing looks like. We call it deep developer's profile. Why is it deep? Because it's not resume. It is much beyond that. It is enriched with a lot of the signals that we are fetching during the waiting time period. And what are those? So you get to know the skills and the weighting result around those skills. So you know what is the rating for this person's skill in lieu of his years of experience. Okay. You get to know what are the other skills that a person has. You can see the work history. Not only that, if there are screenshots of that, you can see the screenshots. Uh, the work history gets automatically tagged with the relevant skills. Uh, this is our seniority assessment. So you come to know at what seniority level the person is. The person may have experience of 8 years, or the person may have experience of 13 years. But what are the seniority attributes that the person is showcasing in terms of engineering excellence, people skills, communication, project impact, and so on, right? Then the pre-weighting of the skills, because we are taking MCQs, we have a further breakup of understanding the sub-skills for that language or for that technology or for that stack. For example, in case of Python, does this guy know tuples, basic operators, list, dictionary, error handling functions, also all these kind of things. And there are surprising things that some of the times we see as a difference between the actual reality and the claimed experience that people have, in their CVs or resumes. Now, when these people are working with Turing for the customer, okay. So by the way, I just want everyone to notice here is there is a huge difference between how job portals operate and what Turing is doing. Okay, Turing is not a job portal. Turing is a company. Okay, it provides services to the customer. So the developers become Turing developers. Okay, in a way they are Turing staff, Turing's employees, working for the customer. Okay, so when the customer selects somebody, that person is hired. Okay, so it is like a services model for the customer, but there are a lot of differences. At the same time, it's not as simple as that you found your candidate, now go and do your business with them. No, Turing is always in picture. Okay, we are responsible. We are, the entity who takes the ownership of that candidate, as if the candidate is a Turing candidate. Okay, so when the candidate works from Turing, then we have even further data, about his performance on the projects, the quality of code that he writes, and communication skills, and so on. So this deep developer profile that you see is not a single extraction of a few things. It is a continuously evolving asset, and which means that it is in a technical knowledge, it's a continuously modifying feature set, or it's a feature store that has continuous updates based for every candidate who is on Turing. So as you saw, we want to build deep developer profiles to make high quality matches. Okay. Now, where do the signals come from? You saw that signals come from the resume. They come from Turing's programming tests, the skill tests, also interviews, also data from prior match attempts, and data from actual work. Okay. So even if customer has tried to acquire a particular candidate, but it did not go through because of some lack of experience, or some negative feedback, or some missing attributes. These get captured as an interview feedback from the customer, and those also become the signals for the candidate, right? Now, you can have all this data, but to train your model, or to do anything predictive, or to do anything data sciencey, you definitely know, okay, who does the job of now labeling things, how, because if you want to train any classifier, you want to train, any predictors, how would you otherwise do that? So the labels come from the actual outcome data. The actual outcome data is how many times the candidate gets matched against the job, how many times the candidate gets picked up for the next stage, how many times the candidate has probably received a good enough feedback there, and so on, right? So based on these actual outcomes, the data gets labeled for various attributes. So it is not any manual intervention, because uh, there is no one who can do the judgment of this quality rather than the customer speaking about it, or the actual action talking about it. Now, the second thing is we want to maximize the information gain per unit time. Okay, so there was a point raised by Dinesh during the discussion earlier, that everyone is talking about AI/ML and using it, and does it really make sense always? And is it useful? So the answer is everything is useful in context of the business outcome. By doing something, what is the return on investment and gain that you are achieving? Now, your AI ML model is worth only of that. Okay. So do you need AI ML? The question has a lot of angles. Do you really have data? Do you have good quality data which you can trust, which does not have a lot of bias? Do you think it is going to continuously evolve, and do you think it is going to get enriched? Do you think whatever you build as a AI/ML model is better than going to be better than a coin toss? So you build a binary classifier which has a 53% accuracy. Somebody can do head and tail and get 50% accuracy. So So you know how much extra value is it adding, and all such kind of things, right? So the first answer for anyone, any company, to go on the path of data drivenness, okay, is to be able to measure things. Okay, can you measure important KPIs? Can you measure important uh, important uh, feature values? Can you really see your performance? If you can't measure that, you can't improve it. Okay. So if you are going to do anything for improvement, first you should be able to measure, and always start with pure play basic KPI analysis. Okay. Define what your business KPIs are for various departments, and just try to see if you can measure your OKRs. You know, if you can measure and you can derive your OKRs, that is the right first step, and we will see that. Okay. Do AIML only if that is going to do much better than your baseline model. And that's what we are seeing here, that you will see that we have lots of AIML problems at hand. Okay. But we choose the ones which are going to give us maximum information gain per unit time in the Turing weightage process. So what can those be? You know, can we shorten our tests? Our Python MCQ, let's say, has 60 questions. Now we have data over so many millions of candidates, and let's say thousands of them, tens of thousands of them have taken the Python test. Okay, we know all their answers to all the questions. We know the difficulty levels of the questions. You know, we need to find a subset which provides the maximized output by omitting the ones which are not giving a lot of signal. So that's how you can keep shortening the test without the loss of predictive accuracy of the test. And as a part of that, our next step is just to make these things adaptive. You know, so it's like any interview. You can keep asking a set of questions depending upon the answer of the previous one and the difficulty of that. You can go to the next one in a sequence of 8 to 10 questions. You know, yes or no, right? At least for that topic or for that skill, and that's the adaptiveness. And now, because we have a lot of signal here and a lot of data here, that's our next step. Okay. So that's our second high level objective. The third objective is, now we have data, you know, can we complete the missing part about the developers? Can we know our developers much more than what they have claimed, what they have said? So predictive models that can actually predict the score of a candidate for a particular MCQ, even if the candidate has not taken it. Okay. So we have data analysis tests, we have machine learning tests, we have Python tests, we have SQL test. Okay. Looking at the machine learning test and the Python test, we definitely can say something about the data analysis skills. And so can we predict, let's say, even if the person has not taken the test, or let's say person took it only for the half time and quit it. Okay. Can we predict and can we, you know, do completeness of this? Now we have 1.4 million developers, right? And they are at different stages. Okay. Some people have taken couple of MCQs. Some people have taken MCQs and coding interviews. Some people have, you know, not done seniority test and so on, right? Uh, can we predict ahead of time who will be most successful, who has higher chances of getting selected? Um, if we want to, if we can do that well, we can fast track those candidates, right? We can tell them that, hey, your chances are great for closing a job. uh, why don't you just take this one test and let's say you'll be able to appear for interviews now. Now this is the third objective, or a higher level objective, and then we will now see a lot of other use cases, right? But prior to that, I wanted to talk about data driven culture. Okay. From what you see, probably it appears that Turing has a search matching problem. Turing does deep developer profiles by extraction, some NLP magic, some ML, sophisticated modeling, and so on. And it meets customer demand, right? Which is true, which is the core of the problem, right? But the beauty is we don't just use AIML for the product in the product. Okay, Turing uses AIML for everything. Okay, we are a out and out 100% AIML company, and when we say that, it means that all our business functions and all different departments and people take their decisions based on data and analytics. Okay. So I was talking about where can somebody start their data journey, right? And this is this is a Deloitte article taken from that. So they say that there are 5 stages of the maturity scale, right? One is analytics aware. So analytics, it is important, but you are not doing it. You just don't have any infrastructure to do that. Second thing is some localized analytics, some adopting building capacity in silos. Okay, some function is using it, some part is it's getting used. Probably you have your web application getting tracked with Google Analytics. So yeah, you know who is accessing it at what time and how many from mobile and how many from Apple and from Canada and all of that. Yeah, good, but it is only there. Okay, so that's kind of that's the localized and in silos kind of analysis. Third is like you have analytical aspirations. So you know that you want to go beyond silos, you want to break them, and uh, you know make it make it go to your mainstream business. Now, then fourth, you not only look at the obvious data, but you try to look at the other relevant data sources. You try to bring them in also for your analytics. But what we are talking about, and what I'm very glad and I can proudly say is at Turing we depend on analytics to manage performance, preserve value, create new products, sources of value while keeping pace with all of this. So when I say we use it everywhere, where do we use? So we use it in all these categories. So this is typically the percentage of people or companies using analytics for the purpose given on the left hand side. So we use it for business process improvement. You use it for customer experience. We use it for guiding company strategy. We measure everything based on KPIs, which are data driven. Our marketing communication strategy depends upon that. We create or modify product and services. We monitor the competitive landscape. Everything is data driven. I'll just give you one small example of this. Okay. So over, let's say, last 6 months, we know how the demand for a particular skill, let's say React and Node, uh, has moved. Uh, in the last 6 months. Let's say if you look at that, we can predict that how much that demand will be 3 months down the line. We do that. Okay, we do demand predictions every time. Okay, and it is regular. It's not only at the month end. Basically, it's continuous. Now, you know that at 3 months down the line, this is your demand. At 3 months down the line, try to find out if your supply is going to meet it. If your supply cannot meet that demand, it means your supply needs to increase in that direction in the 3 month period that you have, which drives your marketing and you know uh, Facebook and other ad campaigns, because then your ad budget should be used in part for that particular skill, You need to know that, okay, I want to reach out to React and Node developers. Now, that also uses the fact from which geographies and from which countries you get maximum response there. So you use it there as well. So what I'm saying is marketing and communication strategies use the demand prediction model and the supply prediction match to derive their strategy, right? This is the full circle data driven AIML business, and that's what we do. And hence at Turing you would see that the size of our engineering team and the size of our data science team is almost similar. Okay, so typically the ratio is you have 10 developers and you have one data science expert. Okay, uh, we our case is exactly the it's quite different. You if you have 10-12 engineers, you also have 8 to 10 data science experts. So and the reason is that the AIML is not only for the end use case of the product, it's for every business function, and that's what Turing does. And how it is done, again, many of you know it, but let's no harm in going through these steps. Understand the business problem. You develop a data approach to solve the problem. You determine what type of data you need. You establish methods for data collection. You ensure quality of those inputs. Then you prepare the data for modeling stage. You model the data to aid in communicating insights. You validate integrity. You verify the effectiveness. You share the data with decision makers, and you address the gaps with greater transparency and create a feedback loop. Okay, so this is what is the process which we follow for every business problem that we solve. Okay, sometimes you don't get a perfect answer for every step. For example, the growth that we have had, we initially did not have a robust ETL or data pipeline for everything. So we lived with that constraint. Now we have it, okay, because we couldn't stop to just build it. The data, the registration, the demand was growing so fast that we had to live within constraints. But we did that. Okay. Now, initially, I can very frankly tell that we had Google Cloud, we have BigQuery working as data lake. We were connectors. There were connectors, fetching data from Live, from Salesforce, and some other sources. But yeah, I mean that's what we had, and then we used our Python Jupyter notebooks and some deployment of AIML models, but it was not really end-to-end CI/CD MLOps type perfect answer. Now we have Airflow, ETL, and MLOps, complete team, feature stores, versioned features, version model, everything. But so you may not have a right answer for everything. That's okay, but you need to be aware of that. You need to take a conscious next step, and you need to fix that in the later stage. But that's how you become AIML driven. And now that I have touched upon this, let me move to some specific AIML problems, a couple of them. So, so what are our data sources? We have tremendous data. Okay, one is customer data. Another is Turing.com data. That is our website. Okay, it's not. It's the company's external face. Okay, but we have people visiting there. We have understanding of what they are looking at, what they visit, what they see, what they want to know about, which podcasts are they listening to, all those kind of things, right? We have campaigns going on. People respond to campaigns. They come to landing pages. We We have all sorts of data for that. We track, of course, our sales people are putting all the customer data, all the customer interactions into Salesforce. There are job descriptions of various jobs that customers have. There are CVs of so many candidates, their answers for different MCQs. Beyond that, there are developer features that we talked about. We have calendars information. This is a calendar where the customer and developers are talking about their availability for work as well as for interviewing. We have interview data, how the interviews went, did they happen on time, did the candidate uh, drop out, did the customer show up on time, up to whatever was the feedback and a result of that interview. We have information of the searches that happen, because earlier for every customer request, Turing used to send customer a packet. A packet is a set of candidates and their profiles to choose from. But now the customer can also do this in by on his own. So there is a search portal where the customer can go look at the candidates, and then you can imagine the kind of data that we need to keep for our improvement of ranking as well as the personalization experience for the customer. So everything like what was the search query, how many times the click happened, which profile got viewed, which candidate did the customer spend time on, all those kind of things, right? Feedbacks, communications. Now these communications are communication between Turing operation team and the candidate, right? That your interview schedule, please take so and so test, and let's have this kind of discussion and all those kind of things. We have developer communities. So Turing has is also supporting a lot of different developer communities, creating events for them, helping them grow in various countries. We have that data. And we have post-match data that after the candidate gets matched and gets selected by the candidate, what happens. So you can imagine the kind of data sources that we have. One interesting point here is all of this is relational, semi-structured, or text. Okay. There aren't any images or videos right now. That doesn't mean there isn't deep learning. Okay, so yeah, the people associate these two things rather very closely, but no, we use a lot of deep learning models for some of our work, and we will see that. Okay, so again, if let's say you look
Yeah,
at, yeah, so if you look at uh, Turing business, uh, you would see four things, right? Demand, which is the customer side, understanding the customer need, reaching out to the customer, and making sure that they get what they want. Uh, Supply, which is the developer side, reaching out to new developers, vetting them, understanding, creating their profile, and doing the matching to bridge this demand supply needs and make it a win-win situation. And finally, growth, growth for both the sides, right? Demand side as well as supply side, reaching out to the new customer campaign, reaching out to the new developers, and growing the numbers. Okay. Now, there is operation, there is pre-sale, there is finance, there is marketing, all of this as departments. But these are the four major things. Okay. You would see machine learning gets very heavily used in all of this, and the other departments are analytics is very heavy. BI kind of analytics and data science is heavy. Machine learning is used in some subsets. Here the weightage is completely different. Okay. Yeah. So uh, now let's go one by one. Okay. Let's say demand. Okay. So if you let's say now at Turing you have customers job profiles, and so what are the kind of machine learning problems somebody can think about, that we may like to solve. I mean, I'm just curious. Just anyone can feel free. There's no right or wrong answer, but I'm just asking this.
Appu has asked, like, it seems every company claims they use AI and ML in their products. How do those companies or those products evaluate their own AI, whether it is good or not?
Oh, very nice question, and I can answer that. Okay. Uh, so how does any company evaluate how they are doing? Okay. Basically through KPIs and through metrics. Okay. Now, either they are business KPIs, business metrics, or they are product KPIs or metrics driving the business growth and objectives. Okay. For example, let's say if you are doing some kind of recommendations to the customer to do cross selling, you know, what is the metric that you will track if the additional increase happened because of that cross selling effort, right? So from whatever I recommended, how many got picked? Okay. Has my numbers grown due to the recommendation? Has the stickiness of the customer gone due to that? Has the ticket size of the order increased because of whatever I have done? Okay. So this is one way to measure those things, and this is the definite way. Or it just takes some period for you to gather and know about the effectiveness. Second way that most of the product companies are aware of, I don't know how effectively they are using it, but I'll speak about it at length, is A/B testing. You device, what is your changed intelligent product route, okay? Release it to a subset of customers and keep your product behavior as it is for the rest of the customers, and now see the difference. Okay, see the difference in terms of the usage, see the difference in terms of the interest, see the difference in terms of the end transaction or whatever, and that difference itself shows you that who is the winner in this strategy. Now if your AIML driven strategy is a winner, it's working. If it is not, it is not working. Okay, it is always the always the end user or the design business impact has to define or has to tell you whether it was right or wrong. Okay, because it may be a great thing. You might have come up with a great algorithm, but the problem is it needs to work for your business goals. So that's how you measure. I hope that answers your question. Now, the second thing is from
Anish.
Gaurav. Yeah, the Mr. Thodla, skill extraction from job descriptions. Absolutely, that is one of the machine learning problem is of good interest for us. I'll talk about that. You're right. Now, how inference on such a varied data is made possible, Gaurav Kulkarni? Uh, Great question. Okay. Now, the for, the simple answer is you have to make it possible because you don't have answer or you don't have an alternative, right? I can't say that, oh, this is varied, looks different, so let me ignore. So nobody can do that. Okay. Now, yes. So one thing is you bring it to something common, which is probably the common subset or which is analyzable. Okay. So for example, you might have heard the term data lake, right? The thing is like you dump everything there and then you extract things, you make them look similar so that they can be joined, they can be considered together, and then you analyze that, right? The another way is you do ETL. Okay, so when from your data source you create a ETL pipeline which extracts, transforms that data and loads it in something else. Okay, so that transformation takes care of achieving the or reducing the variety. Okay. Now that's the answer. So basically, you need to have your ETL pipelines, and those ETL pipelines will help you get the data into a common, a bit less varied format which you can process, and then you handle that. So that's how you do it. Now, there was another question, right? How your model continuously learns, as in when you get a new developer profile. Absolutely. So this is an MLOps question. Okay. Now, once you know how to learn, you just need to take it to a step where you need to continuously learn, right? Now, what are the problems with continuously learning, that we feel? The problems are like we are, or many people, they start their ML journey as a Kaggle competitor, or, or during college. Okay, so you have access to all your data, you take it, dump us into a CSV, you train your model, and you give your test data and you see the outcome. Okay. Now, it never works in the real world like that, because there is no time you will be able to download the data, train your model, upload the model, and so on, right? So you need to think about it as an engineering problem. Okay. So what is it that happens? Okay. So one is like you should be able to train anytime. Okay. Then while you are training, your model that gets created should be automatically testable, so that you can know if that model is correct or not, or if it is like there is some blunder, error hasn't happened. You do that by understanding your model characteristics. So what is your class distribution amongst your model, how much of positive versus negative examples are there, and so on, right? So if you see a drastic difference in the statistics of that, that something has gone wrong. So you should be able to redo that process. Okay. If that validation is correct, you should have a capability to version your model. Okay. So that, okay, this is my model version 1.5. Okay. Then your engineering deployment should be able to deploy any version of the model anytime. Okay. So you should be able to say that, go back to the previous version, something has happened. Okay. Or load version 1.5. Okay. And something like that, right? So all of this comes under the CI/CD of machine learning models. Okay. And you can go to YouTube, say MLOps using AWS, or MLOps using Google Cloud, any cloud of your favorite choice. Okay. And you will see the examples of that how a model gets versioned, how a Docker image gets created with that model, and so on. And then there are advanced things that people also do, that during training, they spin off more AWS instances because you need more resources for the training. Once the training is done, the AWS instances are relieved, and so on. So this is a very, very, you can say, well-practiced engineering field. Just I've just gave you the glimpse of that, but explore it by going to YouTube. You will get your answer there. Now,
Mukul, I had a follow-up question because many would have, so I hope, like, people do understand DevOps a little bit well. Like whenever there is a new code change that goes on a pipeline and gets deployed into production or development into and so MLOps is also same. Like there will be a model whenever there is a new data comes in that goes into a pipeline. That model gets trained with the new data and gets deployed, something like that. So why can't it be called as DevOps itself? Why it is called as MLOps? Maybe in your thoughts. I had this question because the process is same. Then why there is a new name?
Uh, it's a good question. Okay. And somebody has asked me for the first time it to me. Okay. So I'll tell you why I think that it should be called MLOps. Okay. One thing is there are certain peculiarities there which you don't understand unless you are aware of ML field. Okay. And one of that is this validation and testing of your model. Okay. It is not that you can run some JUnit test and say that, yeah, it worked. Okay. That is one problem. Okay. Second thing there is, during that, you also need to check if your data had changed. Okay. How do you say that your data had changed? Okay. For example, suddenly, some geography started flooding your e-commerce site. Okay. You need to understand that, the primary statistics of my input had changed. Okay. You should be able to alert somebody that, oh, hey, wait, this is not a regular increment. Okay. Now, that you cannot do with just DevOps processes. DevOps doesn't care, right? DevOps does not look within anything,
Mm.
right? It is a tool, okay? It is not a lens, okay? But here you require both.
Understand.
Maybe that's the reason, okay? Historically, I think maybe it just the term MLOps just attracts right kind of audience and attention, right? Why would a statistician and a math heavy person go and look into DevOps? Okay, they never cared, correct? Now, so probably this is also a useful nomenclature to address a particular subset. So these are the two reasons in my opinion. Okay, but nice question.
Yes.
Bal Murugan, all your answers are very, very valid. It's predicting skill demand, probability of a candidate getting picked up, and ranking a candidate for a profile. Absolutely, yes. Okay. Now, I'm asking for reading the last question by Sankar Raman. Many job descriptions ask for the technologies under the sun that candidates should have for that position. Does your Turing AI model filter those kind of loose job IDs that you get as requests from the customer? Excellent question. Now, the answer is lies both ways. Okay. So earlier we didn't. Earlier we were more reliant on the pre-sales team having a discussion with the customer before the job description gets formed. Okay. Now, a lot of times the interaction helps for the customer to modify their expectations. But what you have said is very, very relevant, especially right now, because now we have a self-serve portal for the customer. The customers can go search on their own. The customers can go and do their own posting, right? Now, how many job descriptions ask for technologies under the sun? Okay. I will answer this that our models take care of this internally uh, because of the embeddings that we have created and used and trained. So the embeddings themselves from the CVs understand that these things have gone together inside a project. And you know that a lot of times, React goes with Node, React and Node goes with JavaScript. But if you want to know that, okay, and many a times, the Node deployments happen on Heroku. But if you say that, okay, I want a React Node developer on a VMware cloud, it is something which is very, very odd because the embedding does not capture similarity between those vectors, right? So it happens, the model takes care of it in certain way and in this fashion. And you will probably capture that when I go to the actual implementation part of something relevant here. Now, Deepa, feature engineering process and how the features are stored in the feature store. Is it only batch process or is it streaming too? It is batch process right now. We are converting it in streaming. We We use a feature store which is right now populated as a part of certain ETL processes, and yeah, and we are into the evolution of our data engineering pipeline, uh, but exactly speaking, it is right now in batch mode, and it is not continuous as a streaming thing, because we have certain pub-sub mechanism in the background. Triggers get flown across the systems to understand when the right triggers and right changes have happened. They get stored inside as a batch of changes, and as a result of that, the feature store gets updated, or I would say the feature store gets extended. You know, however, there is a separate process when we are introducing new features. Okay, that is much more involved, where you need to really take care of how the new features will get stored, where do they come from, and whatever you are doing for that is not affecting something adversely. It gets tested also very well. So that is a very I would say that's a very controlled and well observed process now. But the updatation of the existing features is fairly seamless, however, in a batch mode.
Uh,
Moving back to the original content.
Mukul, we do have two more questions. Can we just take on this session?
Oh,
or?
sure.
Yeah,
We can take that. Okay, Prakash, how did you get the companies interested in this model to hire pre-vetted candidates? What were some of the challenges faced in the initial months or quarters? Okay, this was a very relevant business problem. The founders being from Silicon Valley itself, and the venture capitalists also being from the valley itself, already knew that the problem is of high value and interest for the companies. Okay, you can imagine that for some skills like full stack, or uh, you know uh, somebody like a QA with a DevOps background, uh, you know the is something like SDE, okay, and machine learning people, okay. A lot of these employees are actually in Google, Facebook, and the big companies. They are not leaving those jobs, okay. Many of them, okay. So there is really a hiring challenge in the valley. Okay, you just don't get people. That's the problem. So your first part is, we didn't have to convince the companies. They were just facing that problem. Okay. Now, what were the issues that they were finding? How to reach out? How to ensure that the candidate is right. And I don't have bandwidth to go through this process of 40 hours per candidate just because I want to hire 2 people. Okay. So because it was solved for them, they actually liked it a lot. Okay. I think the challenges in the initial months and quarters uh, were probably of our communication. We talked about the third thing as well. So we have also infrastructure where uh, through which the Turing developer works for the customer. Okay, so there is a Turing virtual machine, and they log into virtual machine, which basically monitors and tracks everything. So there is a stand up can happen through that. So primarily it ensures that the collaboration takes place. Okay, now sometimes those tools were getting developed and they had some features missing. So probably that was one challenging phase, but we surpassed that very quickly. The engineering team very with high priority looked at that problem. The second thing was this interviewing, right? We did not have the live coding engine or the coding test engine in the initial months. Okay, so we had to rely on our own in-person coding tests. So our teams would conduct them by having the interviews getting done for the candidate and so on in absence of any tool. Okay, which was time consuming for us. At the same time, the scale was not that big. Okay, so we could probably manage that, but we solved it by anyway. It was on cards. So once the automatic coding got implemented, that pain point got addressed as well. Now, how do we manage and ensure developer productivity with distributed time zone and no formal management structure in place? Good. There is no formal management structure as it is, but there is as I said, we have Turing virtual environment in which work happens. Okay, so even the customer is not worried about the IP. The IP gets protected. All the monitoring happens only. So the only way for the developer is to work is to get into the environment and do the work. So the environment ensures that the productivity and monitoring gets taken care of. Okay, and for any inputs related to the quality, of course, we have engagement people who get that feedback from the customer, which gets incorporated. So to answer Prakash, that's the way it happens.
Yeah. I think we are done with the questions as of now, Mukul. So maybe we can go back.
Oh, sure. Thank you. Okay. So let's look at some supply side problem. Okay. Now, what is the supply side problem? The goal is missing value completion by predicting some of the percentile scores, right? Okay, what will you do if the candidate has not taken a certain test? You may remind, you may probe. If you send too many reminders, it will also bug someone. And you want to know if it is worthwhile to also make this person take this test. So the answer is you can predict. And we wanted to do that. And we wanted to first find out that can we, and then shall we, and that was the business goal. So what do we have in terms of the data? We had 1.5 million registered developer. We have huge number of resumes or profile. We had 300K seniority test attempts. We had 250K unique people who took tech stack MCQs. A lot of tech stack MCQs taken. And a small percentage of this done for automated coding test manual technical interviews taken, right? Now, from this data, we wanted the output to be, so from this actually, we wanted to predict using a regression algorithm, the score of each developer, okay, if not present. So if the MCQ percentile is not present, try predicting that. If the ACC score is not present, try predicting that, okay. Now, you can imagine that from the MCQ and from the coding test percentile and from the rest of the features, you can getting a signal on seniority versus getting a signal on MCQ percentile from the rest of the data. Well, all of these are not in same bucket. You can probably do one thing better, probably the other thing may not happen better, and so on, right? So what are the features that we could test? And somebody asked about NLP usage into this and so on. So we could we can use TF-IDF, which is term frequency and inverse document frequency of words in the resume or summary or whatever. Or we could use word embeddings and a model like Word2Vec. Those who are not much aware of word embedding, basically they allow you in very crude terms, you have word in a conceptual vector space. So the embeddings or the vectors, words are represented as vectors in that embedding space. And those which are conceptually similar happen to be similar in that vector space. So, so other than that, so we could use this. The other features were cosine similarity between skills and these vectors, total years of experience, self-declared years of experience, calculated years of experience. Calculated is like our mechanism. Just because somebody says he's 15 years, we also look at the resume and we try to calculate, okay, fine, the person may have spent 15 years, but what experience years we should call it. Okay, it may be worthy of saying only 10-year experience or whatever. Presence of keywords like lead, manager, senior director, VP, and so on, architect, all that. Presence of various schools and companies, if a person having worked in Facebook, person having worked in Infosys, person having worked in, VMware, person having worked in Veritas, these are all have different connotations to that. Person being from particular schools and colleges, again, they have their own value slash, importance. Depth described in various projects, right? I mean, you see a lot of mobile developers, they have, 15 projects, okay? But no link on about App Store or iPhone App Store of that application, or maybe every project is done only in a month or something like that, right? So also the depth, words like mentored, built, hired, and so on. So these are like few identified things. So TF-IDF, many of you may know term frequency and inverse document frequency. Term frequency is how many times the term has occurred. So inverse document frequency considers that common terms may appear a more number of times, but uh, then that should be tapered. Their importance should be tapered. Okay. For example, if I give you all documents on various engineering topics, the word engineering will occur a many number of times, but that doesn't mean it is important. Rather, it is most common. So if something is common across the documents, something like the word like project, okay, you will see that in all CVs, then just reduce its importance. But the word which are not common but occurring frequently, that is measured using term frequency. And I wanted to tell you that a lot of these, okay, these days a lot of stress uh, is given by people in just learning the implementation of models, but a lot of libraries exist that this is just given for free. I mean, you can do it in a 4 or 5 line of code, and that's what I wanted to show you. You can build a TF-IDF vector, so you can give it a resume list, and it takes the features and it builds the TF-IDF model, and it is a 5-line code. Okay, so so what is important is the things that, or the thinking that happens before training the model and after training the model. Okay, and if somebody is trying to learn and wants to be a good machine learning person in next few months or years, pay attention to that. The other thing that you could do is you could use pre-trained embeddings. Now, word embeddings, as I said, are the model that convert a word into a feature vector. Now, the pre-trained word embeddings are embeddings that are learned in some task but they can be used in solving some another task. So it is like transfer learning, that somebody did it for some particular task, uh, and some Google or some company did it who had, really had luxury of hundreds of nodes to train their model, and they have trained the model, and you have the outcome. So why not use it? You don't have to use your resources to do that again. So you could use the pre-trained embeddings. Okay. Now the main library is GenSim. Some of you might have used GenSim. There are many pre-trained embeddings there provided by Google or FastText or so on. In the experiment, we used model are from Google News and Wiki model from FastText. These models is that they give you the weights of for every word as a vector in a 300 dimensional space. So there are 300 dimensions. Uh, Typically, you don't know what these dimensions are. They are conceptual dimensions, and a word is, let's say. So let's say you all in physics had ijk, right? Xi plus yj plus 3k is a three-dimensional vector. So similarly, this has 300 dimensions, and the embedding means that it is 1.2 dimension one vector and plus some magnitude in the second dimension and so on, like that for 300 dimensions. So it's like every word is a vector in a space. So we could take for the resume, we could take the average of all the vectors of the word in resume. So the result is, of course, a 300 dimension vector, because you are taking a mean of all 300 dimensional vectors for every corresponding words. The second you could do is you can take the average of all vectors of all the words that are most similar to the keywords of the problem. For example, in seniority detection, the keywords can be seniority, manage, lead, director, or in Python MCQ prediction, they could be words like Python, Django, Flask. So you use these word embeddings. You use the other words which are vectors which are closer to these word embeddings, and you only consider them and you take average of them, because then it becomes problem specific. Now, rather than just taking the vector, you can also use cosine similarity with the keywords that can be extracted. Cosine similarity, again, go back to your physics. The dot product of two vectors, AB cos theta, howsoever lesser the angle between the two vectors, the cos theta value is more, so the dot product is bigger. So, when the cosine similarity measures that, right? The closer two vectors are, you have a great similarity. So you could use that as a feature for your model. And instead of doing this, you could also train your own word to vec model. Okay. You can say that, okay, I don't want to use anything ready-made. I will train my model. So we have done that as well. Now, how does it look like? So, for example, if you train a word-to-vec model of a resume, then and you take the word similar to Python, you get NumPy, Python, TensorFlow, using Python, Keras, Flask, Pandas, PyTorch, Python, so on, right? But a wiki pre-trained model, Python has similarities with snake, reptile, worma, anaconda, alligator. So this is this is the difference of or advantage, disadvantage of using something pre-trained versus training your own thing. Uh, we not being a really small experimental company, we have a lot hinging on this. So we have invested into training our own embeddings, and we have a huge team or fairly sized team just working on this as a sub problem. So how would you evaluate, let's say, the model? Basically, it's a regression model. So when you have set up anything as a regression problem, you can measure MSE or mean absolute error and split the data set. We split it as 80-20, and then we use two prediction model. One is linear regression, and we use GDBT. We also use neural network regressor for experimentation, but we realize that it causes overfitting. So our models are right now based on linear regression and GDBT both. But we realize that we need to look deeper into the MCQ prediction. Now, MCQ, we have hundreds of MCQs. So also it happens that it's one case that person has not taken an MCQ at all. But typically what happens is they do something. Okay, they take either one MCQ or three MCQs, or they take algorithm and data science, they take SQL, they take React. Okay, but they don't take Node, or they take Python and SQL, but they don't take Django, and all such kind of things, right? So it's a different subset, though it comes under the uh, same problem umbrella. So given a challenge ID, which is the MCQ test ID, can you predict the MCQ percentile for the given skill of the developers who have not attempted the MCQ? So they haven't attempted it, but can you predict it? So of course we looked at the percentile scores of candidates, and as a ETA we looked at various features. Okay, like years of experience, resume length, total length, software experience, and you know relevant project experience summary, all those kind of things. Okay, number of skills in the resume and so on, and we tried to find out the correlation. We did Pearson correlation test and figure out what are the correlations and what are the observations. So we found that years of experience and the calculated years of experience are highly correlated. Our resume features are correlated, project features are correlated, all the experience features are correlated. Okay, but the project and experience features are negative correlation, and this probably maybe because the developers tend to write about the experience more if they have relevant experience, and the project will be otherwise they write it in the lesser terms, and if they don't describe it. So probably if the developer is not experienced, the resume is likely to contain more projects. Okay, the thing that I talked about, like a mobile developer having mentioned 10 applications, but each one being very very small, right? So a similar thing we observed. Okay, so this is what I was talking about, that being a good ML person is about being able to have certain hypotheses formed and confirmed pre and post your experimentations. Okay, and unless that happens, it doesn't matter whether various modeling techniques, and you knowing and answering theoretical questions about how support vector machine works, and it is fine, but won't take you much beyond this. Another important characteristics of good machine learning developers is how they think about converting their features, by applying either sigmoid or log or logic, using such kind of things for normalization and so on, right? So doing the right thing there, understanding why you are doing things in that fashion is an attribute, something which gives you diminishing results, or in that case convert it, using it, a log of it is probably useful. If there is some kind of inflection point, then thinking about using sigmoid versus not, all those kind of things make a lot of value and difference in your outcomes. So going back here, we also looked at interaction between the percentile and a few features for various different MCQs, right? Now, there are certain obvious things that if there are relevant project experiences, the percentile is better. More experience, they have higher chances of better percentile, but developers with lesser years of experience can also score well, not that bad. Count of skill mentions in the resume have little effect on percentiles. The interaction of data analysis are more scattered because uh, the analysis, analyze, all those kind of things which get used as similar words also applies to other areas. Okay. So we built our models to predict this MCQ. What I want you to look at and appreciate is look at the number of models that we have built. Okay. We built a baseline model. We use linear regression. We use elastic net regression. We use Bayesian ridge regression. We use support vectors, gradient boosting, kernel ridge, bagging, extra trees, random forest, histogram based AdaBoost regression. So I think this is another important thing, that if you are doing something which is such a core important aspect of your work, you can't leave some stones unturned. That is one. And treating, using scikit-learn, building one model, saying that, oh, this is my RMSE, things don't end there. Okay. It also does not make sense to, blindly just use each and every model. I'm not talking about that. Okay. I'm saying that you have certain intuition why some model may do better or worse compared to this. If you have that intuition, you test it. Okay. And that intuition is the machine learning knowledge that gets built over the period. Okay. It's not the skill of applying a model on certain data. And this is typically my suggestion to the leaders in this group to pay attention to while building the skills of your own team or while hiring the right people. So this is how we did MCQ predictions. We finally used gradient boosting. And another second problem that I want to cover is matching ranking. So somebody asked that, or somebody said that predicting the right kind of a match for a job. Now, matchability ranking problem is a binary classification problem, or you can give a score rather than yes or no. But you are basically trying to find out how relevant is this developer for this particular job. So basically, every row in the data contains a pair of job and developer, and the successful stages are used as labeled. So if the person got hired, if the person got requested for interview, yeah, you mean that, okay, this is positive. If that didn't happen, you say this is a negative example. Now, we are calling it point-wise modeling because we are estimating the matchability of the developer for a given job, right? Now, what does a typical data schema look like, right? And so we have a matching system where I said that if the customer gives a job requirement, our team creates a packet, sends the matching data to the or candidate profiles to the customer. How do they do it? They internally use our search. Okay. But at the same time, now we also have a self-serve system where the customer can go and look at the candidate himself by doing searches, right? Now, what are the important things that you can look at? You look at what gets searched, you look at the search query, you look at the skill IDs, that got searched for. You can just flatten this with the developer information and see what was every developer's rank in the search result if the developer got returned for that search. Okay, so I am searching for Python, machine learning, and something TensorFlow, right? And my name comes there as a fourth person, so then my dev rank for that query is 4. Okay, and then you also look at if the developer was part of the scrolling that happened in the search result. So when the customer is scrolling through the web page, did the developer show in that? Okay, and if it was shown, then was the developer's profile click, and was the developer profile viewable, okay, and if it was viewed, then was the deep developer profile clicked and checked and all such kind of things, right? So these are the things which probably which provide all the required relevant features for one to build a point-wise estimator or for predictor for job match. Now, so so in information retrieval systems, the learning to rank feature, learning to rank is, so first part is you search and you get relevant thing. And there are things like, how do you expand your query and how do you find synonyms and do exact versus nearby and similar searches and fuzzy searches, right? That's the search problem. The ranking problem is basically the how do you are you providing the ranking in a correct fashion or not? Okay, and you measure the performances of these things typically based on precision recall and various metrics, based on precision of recall. So let's say precision at recall K and so on, right? But you use three types of feature set. One is document database feature set, and that is basically what is getting searched. So in our case, the document is the developer. I mean, the developer CV, developer's profile, whatever it is. Second is query based features. See, the query is either actual search query or it's a job ID or a JD, right? Job description. And query to document based features. So that this is like, this uses various distant functions between the query and document. So we used all types of feature sets. We created multiple data sets, okay? And then we, as you have seen that we use a lot of different models, and these models keep getting evolved. These models keep getting newer and newer techniques get applied. Sometimes but the important problem is how do you evaluate ranking models? Now we saw that we modeled it as a classification issue, that whether this developer is relevant for this job or not. But you can use AUC and precision recall, normal things to evaluate the models. But these metrics are not sufficient because of the following reason. The reason is the classic metrics measure the prediction preciseness on the job developer pair. But our aim is ranking within the job. So we want to say that within the job or for a particular job, is this person better than this person? We are not saying that you predicted this person's suitability with exact or with a very high precision. We want to say that, okay, you did that, but what if you just gave them in a completely reverse order of the ranking? Okay, it's useless, right? I mean, you can pick top 10 guys, okay, but you present them to me in 10, 9, 8, 7, then that's not correct. So and a traditional AUC precision recall curve and so on don't measure that. So we had to evolve our own matrix for this. So I'll show you an example. Look at the left side. For a job A, developer 1 was labeled as 1. Developer 2 was labeled as 1, which means they are relevant. 3 and 4 are not relevant. Okay. And the model score was 0.8, 0.6, 0.7, 0.5. Now, what we are measuring, or what our modified metrics take care of, is we look at developer pairs. Okay. And now we see 1 versus 3. Now, should 1 be topper at top compared to 3? Yes. Okay. What is the model score? 0.8 and 0.7. So has the model done a good job? Yes. Okay. 1 versus 4. Has the model done a good job? Yes. 2 versus 3. Has the model done a good job? No, because the model gave 2 a score of 0.6 when 2 was relevant, and 3 was not relevant, but it was, the score was 0.7. Correct? So now the algorithms that, or the ranking models need to be measured on these metrics. Okay. So the point that I'm trying to make here is, it is one thing to solve a problem, and for most of the machine learning problems, if you frame them right, the recipe is known. Okay, you frame it as a binary classification problem, you know what are the binary classifiers to be used. You frame it as a multi-level classification problem, you frame it as a regression problem, whatever it is, right? I mean, you have the thousands of recipes there along with the source code open on the internet, right? But that doesn't mean you will be able to solve the problem, and that's where many people complain when they say that, oh, we tried to use AML, but it didn't help us much. Okay, it's not going to, because your business problem setting and your objective has not reflected into the way you have formulated the entire solution. You know, we could have used a AUC curve to evaluate our models here, we would have failed, because that's not what we want to measure, and that's not how we want to compare them. So you may need to evolve your own metrics, and you may need to evolve your own features, and you may need to do your own null value replacement, and you will have to do your own transformation. And these are the 4 areas where you make all the difference in AI/ML, is my opinion. Okay, don't quote me outside, but this is what I think, and that's why I presented these 2 problems, and this is how we work at Turing, and as I said, there are many ample number of problems like this. Each one you can model differently. For example, I can tell you that, okay, one guy is suitable for 3 jobs. Which job will you recommend him to? Okay. What is the value of a particular job? Is one job precious compared to another? Based on what? Okay. So you can think of ample number of modeling situation. There is no dearth of AML problems, at least for Turing, because we are extremely data driven. But as I said, that we choose the problems which make the highest impact, give us more information gain per unit time spent. And then once we look at it, this is how deep we go. Somebody asked about, I wanted to talk about how we test our models. Of course, I showed you one way by evolving our own metrics of testing, but another way is A/B testing. So the way people understand A/B testing is, you do offline evaluation. If you find it correct, successful, you do A/B. So for one path you give A, for another path you give B. You see what is successful. If A is successful, you deploy A. B is successful, you deploy B. Correct? Now, this may not be suitable for all situations. There are some situations where, yes, your process requires time to assess and gather things. But sometimes that may not be the case. Sometimes you may want to redirect the traffic dynamically based on how A or B is responding. And there are mechanisms to do that. So I want to just tell you what I mean by it. So traditional A/B testing is, let's say the current champion is orange, okay, and the challenger algorithm is yellow. So your A is orange and your B is yellow, and for 5 weeks, 4 weeks, you have kept A and B, measured it, and oh, okay, B is better. So in 5th week, you made it yellow. So you replace the thing with in the 5th week. This is how most people today understand A/B testing. Okay, but the more dynamic version is multi-armed bandit testing. So basically, think of it is like week 1 you have orange, yellow, green. People are responding to orange, but the response shrinks in week 2, and green takes over. In week 3, green takes over even further, and in week 4, it becomes so obvious that you go to week 5. This looks like the situation of the graph, but that's not true. The truth is even beyond that. The truth is, because week 2 starts looking green, starts looking better, you start diverting more and more users to green. So it is not that if in week 1 50% people are orange and 25% are green, then in week 2 you are sending 40% traffic to uh, green, because it is starting doing or showing better results. Then you start redirecting even further more users to that. Okay, so your end user test set changes dynamically based on the situation. And these strategies, what are the strategies? So the basic, this you can Google or find out. So just remember the names. It's called epsilon greedy strategy, which is a simple strategy. It just keeps increasing the weight. But a more advanced strategy is Thompson sampling, which uses dynamic alpha beta parameters for gamma distribution or beta distribution, and UCB is upper confidence bound, which is another advanced strategy. So I think I would prefer people who are interested in testing machine learning models at runtime as well as static way to look at A/B test and these few things. And if you are a AWS guru, then there is already a ready-made infrastructure and architecture, reference architecture for running the bandit algorithm. So this lambda that you see, it is a bandit algorithm, and you can go refer to the AWS article for how to run this A/B test dynamically with various endpoint models. Of course, this being AWS, they talk about SageMaker, but you can adapt it to your own way of deployment. Okay. Now, having said this, I come to my conclusion. So, probably I hope the talk was useful for you guys to understand how we leverage AIML for our problems. What is our approach to look at it, where we think that the depth of AIML approach comes from, and how we apply it in terms of the breadth as well as depth by extending what is just a standard recipe of things. And yeah, that's what it is. And I hope it at least served the purpose of few of you for coming attending this.
Definitely, Mukul. You have covered both the length and breadth of the session. And would you like to answer a few questions we have now?
Sure. Let me.
Yeah, so it is already present in the Q&A tab. Yeah, the question is posted in the, yeah, you could see. How does the process of ML method work, selection work? Maybe you can go
Okay.
ahead.
So the process of ML method selection is okay. First thing is anybody comes with a very obvious baseline idea. Okay, saying that okay, this is the first foremost simplest thing. Okay, whatever you have to do is beat this. Okay, so first you create a baseline model, then you try to see how much improvement you can make on the baseline model by having at least a couple of better solutions. Okay, then you see that you get a feel that how much you are going to improve based on the baseline. Okay, if you think that you can gain something substantial, then there is a point working on it. If you are convinced that okay, I will have to really work very hard, and for every percent of improvement I'll have to scratch a lot of things, then probably you take a call at that time. Just ensure that there is nothing wrong with your data or validation. But if you think that you have solved the problem to be for it to be applied and for it to be taken to A/B test or whatever, 2 to 3 models are sufficient. Okay, as long as you understand why some model is doing better than the other. Okay, it's a risk to blindly do this unless and until it is a deep learning problem. Okay, that is the biggest disadvantage of a deep learning model, that you just don't know what is happening inside. Okay, so still you can make some thoughts about why it may be working better or not. But as long as you know this, you can do it. We do it in a continuous fashion because we just have a battery of people, and that's our main purpose. So we will fork it out parallelly, and everybody will work on one or other approach. And that's because we have feature sets, we have a standardized way of keeping the data. It's very easy for anybody to keep and run their model on the data set, right? We have if you want to experiment in multiple model, you need to ensure that your data set is very publicly, democratically available. Okay, so then you can do it very fast. So it doesn't take a lot of time really, because all your cleanup code and everything is just ready. You just need to run your model. You also know how you want to evaluate, how you are going to compare with each other. Okay, so yes, I mean that's my answer to it. Okay, how do you balance business delivery versus model effectiveness? No, model effective, there is no effectiveness. There is model, as I said, the model is only worth of the incremental business value that it gives for a business. Okay, so the effectiveness is all measured in the business KPI. If it is not being reached, you chuck out your model. Okay, I mean there is no point having a model for its own fun. Okay, what is the next question?
Yeah, the next question is, as the time goes, the volume of data increases. So data which seems relevant a year ago will become irrelevant now. So how do you handle that kind of
Right,
scenario?
absolutely. It may not become irrelevant per se, it may become less effective. Okay, one thing is, if it is getting if you think that your business case makes it ineffective or irrelevant, you just need to take it out for training your newer models. Okay,
No.
if you think that it is still relevant, okay, as I said, you need to keep continuously checking the input statistics of your data. Okay, I mean, was it that initially you had 80% of um, men giving preferences for shopping? Okay, now let's say 50, it is 50-50. Then of course your behavior probably is going to incorporate a lot of change. Okay, so then you may need to take a call that the model that you had trained earlier probably is useless. You just need a complete retrain, rebalance, whatever it is, right? I mean, so yes, I mean, it depends upon the business context. But if you think it is irrelevant, why would you use irrelevant data? I mean, you don't want to use.
Understand. So Deepa has a question. Do you have challenges of not having enough data? How do you handle missing values treatment?
Yes, we do have challenges of not having enough data. For example, as I said that now we have 1.4 million developers, right? A lot of them have just not faced any customer. Okay, so now we have very small level data. Okay, compared to what we had. Fine. Now the way we do that is through effective sampling techniques, by ensuring that you have right samples of your population. Second, you use some kind of a semi-supervised approach. Okay, that you try to first predict it for a bit smaller set, expand it, use that, and so on, right? So yes, these problems are everywhere. But one good thing about missing value treatment is when you are very sure about the sample population behavior for that value, you could really use that statistics to fill those values. Okay, so you can use the mix of both these approaches for these things.
Okay. So there is another question like, can you talk about the tools used in Turing's data platform architecture to capture data, to store the data, and to process query languages?
Fair enough. Okay. I'll tell you the tools that I am aware of. Okay. Various teams internally also use a lot of things, but I may not know all of them. Okay. Uh, so we definitely use Google Cloud Platform. Okay. We also use part of AWS. We have open source databases. Okay, we get them replicated very well. All of this data, along with Salesforce and the rest of the sources, goes and flows into big Google BigQuery. Okay, Google BigQuery becomes the analytics lake for everyone. There are different analytics and materialized views which are created on Google BigQuery for a quick reference of people who don't have to actually go and look at the schema and so on. There are ETL pipelines using Airflow, which basically allow somebody to create dynamic DAGs and deploy them for the ETL processes and newer ETL things. Then there is a feature store which we use Flint for as a feature store right now, and all the features get versioned and stored inside that. Um, Other than that, we have logs and ELK stack, and Elasticsearch for some of the indexing and quick, fast searches related things. Uh, uh, yeah, that's what primarily the data layer looks like for the processing and BI and analytics. Uh, we use mix of tools. Sometimes we use the Google data platform. Sometimes we use a platform called Mode, which gives you drag and drop quick reporting visualization facilities. If it is ML science or data science work that is happening, we have Jupyter Hub, and people primarily use notebooks. The If you are asking about the lower level implementation, then it is fairly standard. It is NumPy, Pandas, scikit-learn, TensorFlow, PyTorch, and GenSim kind of libraries. Uh, yeah, and we have a separate ML engineering team within machine learning team, which primarily looks after the ML, not, I won't say ML ops, it just also looks at the engineering aspect of the model deployment and versioning and applying it for the data and retraining and all those kind of things.
That's great.
So yeah, that's what it is.
That's great. So before going on to another question, I'll guys, please look into the chat section. Janani has pinged you the feedback link. Please do check it, and it just consumes a minute for you to fill it out. It will be very helpful for us to understand what we need to do better in the future session, especially in virtual. Everything is looks amazing when we look into our system, but we really don't know what the things are other behind. Like what do you want to next? Like either we can go with virtual or hybrid or in-person session. All kind of questions, comments, feedbacks. Please do answer this. So yeah, coming back, Mukul. So determining a candidate or ranking a candidate in a subjective manner is fine, like detecting their skills and all those things. What about the objective manner? Like in every company nowadays, the culture, the attitude of a person plays a they do consider as a main role than their skill sets, right? So how does Turing takes care of that? Because everything is ML based.
I
Then
agree. So one thing is like as I showed you in the deep developer profile, when the candidate joins and starts working for the customer, all these things are getting captured and they get keep getting the part of the deep developer profile, right? Um, the the other only part for us to discover is during our interaction with the candidate, right? And so we have just increased the mechanisms for interaction via developer communities. Okay. Now these are our we have our ambassadors running these developer communities in different countries, and then they know the behavior of the various developers between the developer communities, their interest levels beyond just their job and so on. So right. So that is one mechanism for us to get additional inputs for the developer. Okay. Um, there are few other micro communities that we look at in a deeper fashion, which probably does not give us a lot information about the cultural aspect, but still some of the soft skills. So we look at Kaggle behavior of the candidate. We look at their so, so for example, for that, at least for data science candidates, that's what tells us much more about the candidate than what is written in the CV. But you are right. I mean, uh, we are also not having a lot of leeway into knowing this because even the candidate is unknown to us, and um, yeah, I mean that's so it's
maybe
through the
that would be the
interaction and these things. Yeah.
magic Turing has to solve next. Because few years back, what Turing is doing now is not a believable thing at all. Maybe a decade when you are entering into the field or something. If you tell something what Turing did at that time, people will be telling, "Hey, don't do a joke, just go away." But who knows? Even this behavioral pattern also would be possible soon. Yeah. And maybe I have another question. Like, how about the data governance? Like, Turing captures a lot of data, maintains a lot of data, and there are data scientists as well. How would be the transparency of data? Because few things might be very confidential, even those data scientists would not be seen, right? But for some specific use cases, you need to share a specific data to specific data scientists of your company. So
Absolutely a great question. Okay, so the thing is like we are very much sensitive and aware of this right from the beginning. Okay, so there is a team with this as a responsibility, and that's point number one that which primarily make sure that this does not happen. For example, financial data, right, which is linked with all of these things. You may not really want somebody to know the client financials and some things like that. Correct.
yeah,
The second thing that we use, if it is absolutely must, is somebody who is senior in the leadership takes the ownership of rightly anonymizing it.
okay,
So, uh, you can do it in various ways. You can also ensure that the general statistics remains the same by altering the data. If you know that people are just going to convert it into some categories, then you could just output the categories without giving the real values. So yes, I mean this needs to be consciously done. There is no automated solution for this.
understand. Because a lot of tools are getting emerged nowadays, like Microsoft Purview, Atlan, specifically for this data governance purpose, which is too costly. But the essence or the outcome of the tool it's more important. Like when, yeah, that's. And we already crossed 10 minutes. Can we take one last question, Mukul, before closing, having a closing note?
Sure.
Sure. So Sriram has asked, what is the standard software management process practices followed in ML team? Do you have Scrum, Agile practice, and so on? So yeah.
The team which works very closely with the product team becomes a part of the Scrum, but their own process is never Scrum based because there are so many unknowns. Okay, you just can't say that you have to finish this ticket in 2 days. You may not know. Okay, standard process. It is. It is a mix of like any R&D lab would do, doing your things with deadline and expectations in your mind. You can only do it for ML engineering and analytics work. It is very difficult to do for ML science work. ML engineering, yes, definitely totally Scrum. Analytics also almost Scrum, because it is like create this report and that what I do I need as an input and transformation and everything. ML science, it is very, very tough to fit it in a process.
Understand. Okay. So I think we have come to the end of the session, Mukul. It was very glad talking with you, and you have presented great insights, more both on the breadth and the depth side of the tech stack behind Turing. So when I checked a few months back, Turing was advertising like 500,000 developers are in connected with Turing, but now from your slide, I'm able to see that it has grown 3 times higher. Like 1.5 million developers are get in touch with Turing. That's really amazing. And in a general perspective, during doing a business and earning a money is a normal thing, like anyone is doing. But doing a business that helps out a lot of people, that empowers a lot of people's life, is not a easy thing, right? That is really
Absolutely.
great. And that's what I see that Turing is doing. Turing is connecting people from all around the world, right? From different countries of Africa, Nepal, Pakistan, where they don't get that opportunity to show their talent or earn money, right? To work with Silicon Valley companies. And also I think this remote world, the companies like Turing and people like you who are leveraging the AI and ML in right perspective to the product to empower the people's life is really a great thing. And we are very proud to have you here, Mukul. Thanks a lot for taking this.
Thank you so much, Mukul. It was a great session. And thank you so much, Dinesh, for moderating the session very well. Thank you both. Thank you, audience, for throwing up the interesting questions, making the session very engaged. Yeah, see you in the next event. Bye.